All right, well, let's start. Well, welcome to the AA East Bay. And we had this idea that based on our vision goals for the AA East Bay, one of them being we facilitate solutions to reduce the local housing crisis. And so what we've done is have established the 2 housing forums this year. And this one is a part of one. We're talking about technology and different ideas of wood and how there are solutions there to hopefully help reduce costs of housing in this area. And we have a larger symposium that's occurring on August 4th, where we're going to be exploring affordable housing policies. We're going to have a panel discussion on supportive housing. We're going to talk about live work, as we all are doing that now more and more because of COVID. And then we're going to feature Larkin O'Hurley out of LA, who we got kind of case studies of all those types of buildings and really explore the things that he's been exploring through his career. Just really great design and really trying to help the community. But for today's presentation, we have Chelsea Drenick of Woodworks and William Kilpatrick of Integra. And we found them to be really interesting as a mix. Chelsea's going to be talking about mass timber and how, I guess, July 1st, it's been codified now, and it's a technology that keeps coming up for housing. And then Integra has been doing fully integrated offsite solutions and just seeing how they can really help do 2 things. First, make it more competitive for housing as far as costs, and also help reduce carbon emissions and reduced waste. So I think both of them are really interesting as we are looking at housing, and I appreciate them both being here. We're going to start out with Chelsea from the Woodworks and a little presentation on mass timber.
Great, thank you, Brian. So I'm going to be talking quickly here, a whirlwind presentation on mass timber construction, products, performance, and design. So introducing mass timber products, what a mass timber building looks like, design considerations, and why mass timber is gaining popularity. And then I'll wrap up, like Brian said, talking about the new provisions for tall wood that'll be adopted in 2 days here in California. So before we jump into the content, just a few quick words about Woodworks. For those who may not know about us, we're a nonprofit organization dedicated to helping project teams design and construct wood buildings. We do a lot of presentations like this, and if you're interested in a longer presentation for your office, please reach out. Our main focus is that we provide free wood design assistance to architects, engineers, and others in the building industry. So ask me your questions, bring me your challenges. We do light frame, mass timber, all wood construction. Our focus is on commercial and multifamily. So we don't really get into the single family homes, but larger wood projects. So I'm the regional director in this area. I'm located in San Francisco. My region is Northern California, Nevada, and Utah. So I'm your main point of contact for any help from Woodworks. A bit about me, I joined Woodworks 10 months ago now after 9 years in structural design consulting here in the Bay Area. So hopefully we'll get to meet in person soon since we are all located in the Bay. So please reach out with any questions you have. I've been fielding a lot of questions on mass timber recently. Everything from, supply in terms of manufacturers to what sort of coating should we have, insurance questions, and so on. So any questions, I will help you find the answer. So the reason we can provide free assistance is because of our funders. Our main funders are the Softwood Lumber Board, the U.S. Department of Agriculture, and the Forestry Innovation Investment. We also have a number of funding partners that are manufacturers. So we're talking to them all the time to understand what's going on in the industry. And we can also connect you with them. So if you're interested in talking to mass timber manufacturers or light frame manufacturers, we have a directory on our website as well as a contact sheet. So we have a number of online events, workshops that are all taking place virtually right now. We have one on multifamily detailing, structural detailing coming up in July. That's light frame focused. And then we also have a mass timber construction management half-day workshop in August. And this is just one of the examples of our resources on our website, a case study of a Sacramento project where they used a AMMR to approve a 6/2 project. So some cool stuff on our website. All right, so let's get into this, talking about mass timber products and then some design considerations. All right, so what is mass timber? Mass timber construction, I like to think of the delineation between mass timber and heavy timber. Where heavy timber, it's the historic type of construction. We're thinking of a solid wood member, a solid 8x8 for a column, a big 10x14 solid wood beam. Mass timber can have these same size elements, but it's made up of a number of smaller individual wood members. So they're laminated together, either using adhesives, nails, screws, or another type of mechanical fastening. So here's a visual comparison that I like a lot. This historic heavy timber on the left, mass timber on the right. One of the old adages with heavy timber was large column, large tree, meaning that every single large piece of column cross section needed to come from a single tree. That can be hard to source. If you need that 12x12 column, you need a tree that's bigger than that. Whereas on the right, we can still have these sizes, that 12x12 column, but instead of coming from one singular log, we can fabricate it from smaller pieces. So we can use commodity lumber products, perhaps even lower grade products, using smaller diameter trees to still produce these similar sized elements, columns, beams, and panels. So I'm going to step through the main framing styles here that we see with mass timber, and then we'll talk more specifically about some of the products. So this is probably the most common type of mass timber construction that we're seeing. This is post and beam. So usually these post and beams are glulam, but they could be solid sawn, PSL, LVL, or another type of engineered wood product. And here they're supporting a mass timber panel floor. So here, post and plate, this is using mass timber as a two-way span system. So similar to what you'd see in flat plate concrete construction. Note, looking down this building, we don't see any beams. It's only columns and flat plate CLT. So this we're seeing more often used in residential than office. And it's because we have to have this tighter grid spacing you can see here than the last slide, which used beams. So one other thing to note with this is they have different grid spacing in each direction. And that's because CLT has a strong and a weak axis, which I'll talk about in a minute. Honeycomb, this is more common in Europe. Honeycomb or house of cards style of construction, where both the vertical bearing systems, so the walls and the horizontal decks, are all mass timber. But we don't have to do an entire building of mass timber. For multifamily, we've seen CLT floors with prefabricated panelized walls used very successfully. And I'm excited to hear more from William about prefabbed walls. But I think this is a great option, just replacing those floor joists, the TJIs typically, with CLT panels. So we can have it exposed, we can get that beauty of the wood, and using it, in multifamily type 3 construction. We're limited to that 5 stories, but it's really a great option, I think. So going the other way with hybrid, CLT over steel framing, maybe this is the best fit for your project. We're seeing this a lot in office projects where you can get a little bit longer span. So another thing to consider. So of those different styles, we saw a lot of different mass timber products. So let's take a look at those quickly. Glue laminated timber, glulam beams and columns. These have been around for 100 years. I know I used to use them on light frame construction for longer spans when you didn't want to use a steel beam. They come in a number of different grades. Industrial grade if you want to hide it in a wall, or a more architectural finish when it's exposed. Very simply, just 2x that are glued together, then planed down. And so this is very common for our posts and beams in glulam buildings. There's also glue laminated timber GLT, which is a floor panel option. So that's actually what's shown here in the photo on the left. It's basically a glulam beam on its side and used as a floor panel. Nail laminated timber, NLT, very simply made up of a combination of 2x members, usually 2x4, 2x6, 2x8. They're oriented on their narrow face, so their strong axis is in the downward direction. Just multiple laminations laid up side by side. Each lamination is nailed to the previous. So NLT is usually used in horizontal applications as these floor decks, roof decks. We're always going to be adding plywood or OSB to the top face to have in-plane shear capacity for that diaphragm. NLT, they're interesting, and it's something that can be prefabricated off-site and just shipped to the construction site, or it's something that can be built on-site or in place. usually not built in place lamination by lamination. But this is kind of really different than other mass timber products that are always prefabricated, typically by a manufacturer. And I think NLT was more popular when mass timber supply chain was less mature, but now that there's a number of manufacturers, CLT manufacturers, for larger projects, it's more cost efficient to go with a prefabricated panel. However, recently there's been a lot of interest in smaller residential projects, or if you have like a feature conference room, the contractor on your project can build NLT right on site. So kind of a cool thing to think about if you're wanting to have that exposed look. One thing to consider with NLT, since all the grain is running in the same direction, is there's shrinking and swelling while the moisture content varies during construction. That's why using an expansion joint, as we see here in the bottom right photo, or simply leaving out a lamination every panel, which is about 8 to 10 feet, will allow for that movement to occur during construction without causing damages. So then that allows the moisture content to reach an equilibrium, and once the building is closed, you can fill that gap. And this is different than CLT, which is dimensionally stable, which I'll talk about in a moment. So this is T3 in Minneapolis, a spec office building. Hines, the developer, is making a splash in the marketplace with mass timber buildings. They've had so much success with this project, they're building in other places as well. T3 Atlanta is complete, T3 Denver's in design, also in the works in Canada as well. Next product, Dowel Laminated Timber DLT, very similar to NLT in terms of the members that make up DLT. 2x, or sometimes I think 4x, vertically oriented. Instead of nailing to each other, a hardwood dowel is driven through them to connect them. What's cool about this product is there's no adhesives, no nails, only wood. So here's T3 Atlanta, very similar to the T3 Minneapolis project. Again, it's 7 stories. This time they use DLT, and it's over 200,000 square feet. So here's the product everyone's probably heard the most about, cross-laminated timber, CLT. Kind of in the spotlight with this mass timber revolution we're seeing. There's a number of manufacturers here in North America and also some in Europe that can meet the PRG 320 standard required by the building code to use it as a material. Also newly available is CLT with structural composite lumber laminations. Freris Lumber out of Oregon is calling this product mass plywood panel, or MPP for short. So massive layers of plywood basically glued together, manufactured in 1-inch increments, all the way up to 24 inches in depth. So they can be used as plate elements for floor panels, or they can be cut and used for columns and beams as well. So a quick project example here, a CLT hybrid building with MPP floor plates, hybrid with light frame walls. Great project, 4 stories in Oakland, very tight urban site. There was no room for staging. So what they did is they had the walls panelized. Those were all trucked in, lifted into place. And same with the MPP. They had an offsite staging area, and they were lifting things straight from the truck into place on the project. Originally, this project was all light frame, site built. The contractor said it was going to be 14 months for the construction schedule. With the prefab and panelization, they were able to cut down that schedule to 10-month window. So back to typical CLT with solid sans. Cross-laminated timber is formed of multiple layers of these solid wood laminations. So we're putting down these 2x, laying a screen of adhesive. The next layer is rotated 90 degrees, and so on and so forth. So usually an odd number of plies, typically seeing 3 plies, 5 plies, 7 plies. And the reason for that is because those outer plies are running that long direction and are considered the strength axis. The minor weak axis is going in the short dimension of the panel. So unlike NLT or DLT, there is strength in 2 directions. So we can have that flat plate CLT construction. Here's a quick video I have of a CLT panel being made. So we're starting with 2x commodity lumber. The first thing they're going to do is finger joint these end on end. So gluing these pieces together end on end to get to these larger panel sizes. So panels can go up to 60 feet long, typically I think around 40 feet. Then they cut down these longer pieces of lumber to size. Each panel is made for a specific location on a specific project. There's that screen of adhesive going down on that first ply. Then the second ply is cross-laminated. You can see there's an opening in the diaphragm there in this design. and then the third ply going on top. After that, it'll be pressed and go through the planer to sand it and finish it for this 3-ply panel here. There's our final product. So here's a project example, office building in Portland, Oregon, Albina Yard, 4-story CLT and glulam frame structure. So unlike NLT and DLT, CLT is dimensionally stable due to the cross laminations. So gaps between the panels are not required for the swelling and shrinking during construction that I mentioned with NLT. Here's a local project example, Wendaharo. I believe the structure's finished and they're just outfitting it for TI before the tenants move in. 4 stories, a 3-story mass timber over 1-story concrete podium. This project's kind of cool because they were designing it in concrete and mass timber and costing out both. And mass timber won on this site because it's in a poor soil site in Soma. They need deep foundations. So mass timber is much lighter weight than concrete. So they're able to save significantly on the foundations and make mass timber pencil out. So in terms of connections on these projects, connections typically consist of small diameter self-tapping screws or proprietary and custom fabricated beam and column hardware. It's really kind of a new vocabulary of connections, particularly on these large projects. Lots of different shapes and sizes for timber self-tapping screws. Also an ever-improving market of tools to install these longer fasteners easier and more accurately. So I mentioned how post and beam is very common on these projects. I like these photos because it's kind of 3 different examples of how you can have that post to beam connection. On the left is likely prefabricated, bent plate bearing connection designed by the structural engineer. In the center, we have these proprietary connectors. In the right, there isn't even any hardware at all. The beam is pocketed into the column. One thing to consider with this is how do we account for shrinkage? That beam is going to shrink the width and the height. And you don't want to accumulate that floor to floor, especially as buildings are going taller. So I like this far right one, I think is very creative because the panel itself is just resting directly on that column and bypassing any shrinkage that occurs in the beam. So talking briefly about lateral framing system options, because we're in California, code process turns slowly. We're working on getting CLT shear walls in the code, but they're not quite there yet, currently in balloting. So most designs are using other lateral solutions on taller buildings and office buildings. We're typically seeing steel or concrete cores or BRB, buckling restrained brace frames used and then hidden in walls. On multi-family projects where we have this hybrid with light frame shear walls are a great solution as well, but then we're limited to 65 feet in height for that wood. Panel to panel connections, we're typically seeing the surface spline is what we're calling it, where they basically route out the top of the 2 adjacent panels, and you can either put a plywood or a thin wood piece here, and then nails or screws. And so that creates this diaphragm continuity across this panel seam. And this is actually in the new structural design provisions for wind and seismic 2021 document. It's not yet adopted by the CDC, but a lot of project teams are using it. The other option is you have to put plywood down over the entire CLT, or you can use a concrete topping as your diaphragm. One important thing to note, if you're expecting rain, you need to tape these seams because otherwise water seepage will get through and you'll have staining on the CLT. So the lightweightness of CLT panels, it works for us for the structural design and construction, but it works against us for acoustics. So we're not going to have bare CLT panels. Typically, we have the ceiling exposed, the underside, and then we have the floor finish on top. Part of the reason for this is it's a softwood lumber product. It's not durable, so we want to add that floor finish on top. So typically, we're seeing acoustic mat, 1.5 inches to 3 inches of concrete or gypcrete. That can be your finished floor, or you can apply a finished floor on top of that. There are assembly options without concrete. We're using then proprietary acoustic products. And we actually have an inventory of acoustically tested assemblies on our website. Talking briefly about fire resistance, definitely a subject of much discussion when you're talking about exposing mass timber. How is it going to perform in a fire? Well, wood As it burns, heavy timber and mass timber in particular, it burns at a rate we can predict very accurately, and it burns fairly slowly. And as it burns, it's forming this char layer on the outside that's protecting the inner wood, keeping it cold. So it can retain its structural properties. So we know through all the testing that's been done, we can accurately predict this char layer formation, and it's about 1.5 inches per hour. So talking with structural engineers, they'll do the design of that, size the member for the loading and your fire rating, and basically calculate how much sacrificial wood is needed for the fire rating required. And that is permitted per code. So we looked at mass timber products, typical buildings, some design considerations. Now I'm just going to go through why is it increasing in use? Why are people interested in it? Our global population is increasing. Where do we house everyone? Where will they work? How will climate change impact where people can live and work? So we need more buildings. We need more housing. But buildings generate nearly 40% of annual greenhouse gas emissions. 28% is building operations. So you can see the yellow things here, that's 40%. 28% is building operations. 11% is embodied carbon emissions. And that's when a building is built. How much CO2 is released due to its materials and construction? So looking at this a little more closely, operational and embodied carbon emissions of structures. Operational is a bigger portion here, but embodied carbon is an upfront cost. It takes 17 years on average here for operational carbons to surpass embodied carbons. So we can have a real impact in the short term by reducing them. And I think the building industry for a long time has focused on operational carbons, which is great. We need to reduce them. And now we're turning and looking at embodied carbons more and more. Operational carbons only improving, greener grids, more efficient heating and cooling. Embodied energy is not insignificant, and it doesn't have to be a necessary evil of building a new building. So one thing that can help with that is wood. Wood is 49% carbon by mass or weight. In other words, approximately 50% of this wood is carbon that was in our atmosphere, contributing to global warming, and is now physically converted into a solid form of wood and put into a building. So whole building life cycle assessments typically show wood buildings as a way to reduce the embodied carbon footprint of a building. So throughout the life of a building, a wood building, it's basically acting as a carbon sink, storing that carbon dioxide. However, one thing to note, it's only sustainable if the forest is sustainable, if the forest remains a forest after the tree was harvested. Here in North America, our forests are very stable. There's a lot of sustainable forestry practices in place and rules and laws around it. And studies have shown the use of forest for wood products actually increases trees in a forest. So I actually have a hour-long presentation just on carbon and wood that I'm planning with AIA California for end of August. So if you're interested in hearing more about this, that'll be on August 26th with their climate series. All right, so the other why of mass timber, exposing wood. Biophilia, this idea that people are drawn to nature. People feel good when they're around natural products. When you see a wood column, you want to touch it, you want to hug it. it's kind of funny. And like looking at these renderings, which one would you like to be your living room? Another driving factor for mass timber prefabrication is the labor shortage. It's existed for many years. A lot of it was driven by the recession in 08 and 09, and it never really recovered from that. So coupled with urban settings, labor tends to be very expensive in urban settings. Mass timber is a way to integrate offsite construction. Then the crew on site can be smaller and doesn't need the same skill set. And this point is tied to the previous. Compressing construction schedules will reduce the requirements of labor. Less time of folks on site. Time is money. And mass timber helps with this. It's a lot of coordination up front, but when it gets to site, it's like a set of Legos. It goes up very quickly. So this is a feasibility study done in Seattle, compared concrete construction for a 12-story tower to mass timber. And they found that there was a 5-month saving on the construction schedule to use mass timber. Developers like to hear that. They can see the return on their investment that much sooner. So market drivers for mass timber, we went through this and I'll briefly summarize. Construction, efficiency, speed, great for urban infill sites, smaller staging areas, this innovation aesthetic, the idea of biophilia, carbon reductions in this lightweightness, where you can reduce foundations. Here in California, lighter loads that go to our lateral systems to make them more efficient. We have a checklist online that goes through these benefits. It's a cost and optimization mass timber checklist. So please feel free to use that if you're interested. I'm not here to say mass timber is right for every project, but if some of these benefits ring true for you, it's worth exploring. All right, so to wrap up here, I'm going to talk about the new code provisions that will be going into effect in 2 days. So current prescriptive code limit for mass timber is within type 3 and type 4 construction, goes up to 6 stories for business, 5 stories for multifamily. And over that, we need an AMMR, which, as we all know, is a hassle. So Europe kind of started this movement, the tall wood movement, and to catch up, a tall wood ad hoc committee was created to explore it here in the States. They conducted 5 full-scale mass timber fire tests in a multi-story apartment building in a lab in 2017. And the key to these tests that they wanted to prove was that they could get burnout of the structure without collapse. So I talked about char, how it protects the integrity of the wood. And that's what these tests prove, that the contents of these apartment buildings could burn the mass timber chars, but the structure remains standing so that occupants can leave. So given the success of the test, the ad hoc committee proposed 17 revisions to the 2021 IBC to include these new tallwood construction types. They were all passed, and the CBC now, the California Building Standards Commission, grouped all these code provisions into one agenda item and passed them to be included as an amendment to the 2019 CBC. So that was published on January 1st, and it'll become effective July 1st, 2021. So 2 days from now. One of the big proponents of these adopting this tall wood provision early in California is our state fire marshal, actually, Chief Mike Richwine. And he noted 3 things that he thinks mass timber can help in California. It can increase the market demand for mass timber production in California, so increasing jobs, increasing scale of construction here. It can increase the pace and scale of our wildland fire prevention and forest management goals. I mentioned how we can use smaller lumber products for mass timber. You know, if we can bring mass timber manufacturing to California, and a lot of people are looking into it, then we can have an incentive to thin our forest, better fire management. And his third reason here is mass timber construction can also help reduce the carbon footprint. You know, mass timber, when we go taller like this, you know, we're starting to compete with steel and concrete for these taller structures, and we can reduce the carbon emissions of these structures. So what are the new code provisions? There are 3 new construction types, and I have a whole hour-long presentation just on these. But to briefly summarize them, type 4A can go up to 18 stories. However, all the mass timber needs to be covered with non-combustible protection, so GIP on all the mass timber. Type 4B, we can go up to 12 stories. We can have 20% of the mass timber ceiling exposed, 40% of mass timber walls exposed. Type 4C, we can go up to 9 stories. All the mass timber can be exposed. So with that, I will take any questions.
You can ask questions via the chat, or feel free to unmute and just ask them if you have them. Thanks, Chelsea. As every question I had, I'd be like, oh, I'm gonna have a question, and then all of a sudden the answer was 2 slides later. So
nice.
Very comprehensive in a very small period of time. Thank you.
Yeah, kind of a whirlwind 25-minute mass timber presentation there, but. And I can share the slides with you if you would like to distribute them as well. Oh, you're muted.
Yes, that would be great. We'll post those on our website when we share the video too. That'd be wonderful.
Great.
I think we'll move on to William Kilpatrick then, and his work at Integra, who is a design and engineering manufacturing company that provides this fully integrated off-site solutions. FIOS. thanks for joining us, and we look forward to hearing about how you are working with wood to really help the industry and help residential and I guess commercial construction.
Okay, thank you very much, and thank you, Chelsea, for that that great presentation there. So just share it. So just to give you a bit of a background on myself, I'm a Senior Vice President of Customer FIAS Integration for Integra. Integra standing for engineering, technology, and rational use of materials and waste. Integra has been going now in the industry in Modesto here in our factory for about the last 4 years. But prior to that, there the management team and that founded Integra have some of us over 20, some of us over maybe 40 years experience in off-site construction. So we decided to look at the US market, having sold our off-site company, which was originally Century Homes back in 2005, and then we stayed out of the market, and then we looked at the United States as a whole. So the one thing that we noticed is that a large percentage of the buildings here are built in wood frame, as they are in various countries across Europe. So in Scotland, you would have maybe 85%, Ireland, you'd have 45%, and then down to Spain, you would maybe only have 5%. Up into Sweden, it could be 99%. But in all instances, no one would even consider stick framing that building. It would all be done under factory controlled conditions. So the first slide that you're looking at there, that's actually going to be a 4-story building that we're doing down in Dublin here in Northern California. That was framed with 5 guys on site. Any more than 5 guys on the job is the 6th guy is redundant, because there's only a certain amount of work that the crane can do. So each one of them walls that you will see in that there slide is fully sheared. So what FIAS stands for, as I said, it's a fully integrated off-site solution. And whenever we mean that there, we mean that anything or anybody that touches or has anything to do with that frame. So we're starting this process 12, 14, 16 weeks ahead, depending on the type of product. So we're looking at the architects, we're looking at the engineers, we're looking at plumbers, electricians, we're looking at all the trades, anyone that touches that. And what we want to do is bring an improvement and an efficiency to the process. So we call it the pain before the gain, is all the questions that we're going to be asking. Where's your plumbing pipe? Where's your HVAC run? What tolerances do you need to fit your bathtub, your shower tray? We're asking all them questions. Where's your tile bar blocking? The more information we get up front, the more we can put in that building to plate. Typically, we will put a 2,500 to 4,200 square foot house to plate in one day. We add an efficiency to that in that day 2, we're loading trusses, and by day 5, we're at shear inspection for that typical house. What does that do to the overall cycle? That means that the superintendent knows on a given day we are going to be finished. He can move his trades in, so he reduces his build cycle from 105 days down to maybe 85. And one example of a house, first house we done for a national builder here in Northern California in Sacramento, the superintendent's target number was 105. If he brought it in on 95, he got a bonus. He took our first house and he brought it in 57. Now, we're not saying you're going to do that all the time, but he wanted to give it a go. He had everybody lined up, and that's what he came in at 57. So I'll start the presentation off. That's just a quick bio there and a quick brief of our company. So hopefully this will work. So what we're looking at in this here slide is this from the, as it says, the Wall Street Journal here. We're looking at the unlearning by doing here, the gross value added per hour. But if you look at the construction industry as a whole, construction industry is actually dropping. So agriculture is rising, manufacturing is rising, but construction is on the fall. And that has a few reasons that is happening, because for every 5 people that leave the construction industry, only 1 person enters. So of them 5 people that are leaving the construction industry, they are your 5 most experienced people in the industry, and you're replacing it by 1 person who has absolutely no experience. So what Integra does is, and Chelsea enlightened it to it earlier there, is we bring a process to it, but we also introduce where you only need unskilled labor. You don't need the trades. You don't need the guy that's going to cut a roof or cut a stud or form an opening, making sure they put in the right header. You can use unskilled labor with one skilled carpenter to lead the crew of 5 guys. So that's just a breakdown from the National Association of Home Builders on the looming labour issues. So this is where I was saying where we have 5 leave, 1 comes in. That's the issues that the construction industry is facing. So for want of a better way to try and explain it, we want to make, pardon the pun, we want to make construction sexy again. We want to make it good for the young people, the tech people of the world that believe they have to go and work in Google and Apple and have to do this here. Why not bring technology to the fore here in construction? And that's what Integra and that's what all the offsite companies are looking to do, is bring technology into the construction industry and bring it up from the archaic methods that are being used, particularly in the United States at the moment, where a lumber drop is done on site today, and then you'll have 5-10 guys with skill saws cutting 2x4 over their boot, scaling, lifting walls that are too heavy for themselves. Then they have no shear fitted, they have to get scaffold in place, and they've no skill set to do that there. So what we do is we bring efficiency and quality to the whole process. So I believe this may be a video here, so hopefully it'll start up here for you. Okay, so that was just a short video of our factory. That project that you've seen at the last there was for Toll Brothers in Daly City. So the typical frame cycle for that there house for the framer, that was a takeover job that we done, was somewhere between 70 to 80 days. And we were doing it in 15. That's to shear, and that was a 4-story split level, complicated, not an easy build. So it's a great project, and it's still ongoing at the moment. So this slide here it's like the difference in technology. So if someone had asked Henry Ford what people wanted back in the day, they probably would have told him faster horses. So we're now at the point now we've now got electric cars. We've now got telecommunications. Everything has moved on, and that's what we want to bring to the construction industry. Again, this is where we're at now. That's where we were, and this is where we're at now. But believe it or not, in most of any stick framing buildings that are being done currently at the moment are still being done as we see on the left hand side there. So I'm not sure if you're all aware, but I think the price of lumber went up by 350% over the last year. So what we bring to the table is the drastic reduction in the amount of waste that we produce. The waste that comes out of our factory is minimal because we recycle and reuse for blocks in walls or to make various other components like arches. So if you look at that material that's lying on that site there on the left, that's seasoned, it's weathered. That building has no shear installed on it. So whereas our building comes to site fully wrapped, we do not supply walls without OSB or shear on the outside of the wall. We believe it gives a far better quality of a home, and now some of our customers are even sending us back reports on improvements on air tightness and quality of build, and using it as a selling product for their home. Oh, I think I have another video here, sorry. Okay, so it's all about antiquated offsite practices. So if you were a home builder today and you're looking to build a house, the first thing that people will always tell you or say to you is, oh, offsite is more expensive. It's going to cost you more. It's going to just going to cost you more. But if you had the option of getting your car, getting all the parts shipped to your front lawn or rear yard, and some guys landed and started to build it in your rear yard, or if you could have it manufactured under factory controlled conditions in a factory, what are you going to take? You're obviously going to take the factory controlled condition. So why not take that there for the single most expensive item that anyone will buy in their lifetime is a house, is a home. Why not want to have the best constructed home? So with the automation of the machines, we have the files that we prepare, and we've already built the building once digitally, as you've seen in the previous video there. We have built this building already digitally. So we have all our files are stored. So in 10 years time, whenever the lawyer comes round to say, hey, have you any issues with your house, we can pull them files. We can say, here, this wall was made by William on line 1. There was 1,000 nails put into it. The lumber came from Oregon. It was made at 12 p.m. We can have that there. We have all that data stored for each house. So every house is going to be the same. So if I have 10 houses, it doesn't matter what my crew is. It could be 5 different guys on every house, but the stud will always be in the same place every time. So again, another awareness, we had the game changer there last year when we had the COVID pandemic, and what we actually found out was after a few weeks of closed down till everyone figured out what was happening, is that our inquiries for from customers actually increased by over 300%. Now, with our process, you only need 5 guys on site, so we can be separated by distance. We can follow all the protocols that were required by COVID at the time. So we were actually able to keep moving and keep our customers happy that we were following all the protocols that were set out for COVID-19. We say if it's not a system, it's not a solution. So the system is the process and how, when you get that information, when you use that information ultimately to get your building up in the timeline required. So engineering, we engineer, we value, we manufacture, and we assemble, cycle time, and then house ready. Whatever. Keeps wanting to jump onto my videos here. Yeah, this is probably the one. This is just going to show you that. Sorry if this one has jumped in on me again. Okay, so that's obviously another one, but so to get rid of the integration of the hood, we do a slab survey of the concrete. So we're working with the concrete guy. What we do with that, we send them a report back to our customer saying that the concrete's not level, there's hardware in the wrong place. So that's all to do with the integration of the build. So we can design, engineer to basically imagine it's the space shuttle from SpaceX that has to land back down on their pad. So that's, we're basically landing the house on the pad. So how's offsite creating value? So we have streamlined high performance solutions. PAS helps builders be more productive. So a fully integrated solution will reduce the total build time by streamlining the process. Building sustainability, reduce the carbon footprint by optimizing material and building processes. Predictable high performance, eliminate redundancies and field issues before they can become costly job site headaches. outperforms other building methods. That's a given. Any method that, as in like stick framing, we're going to be a lot quicker than them. And the quality of the materials that we only use kiln dried premium grade or strip one lumber for our studs. So this is a house that we put up one day, and we actually dropped the roof on it at the close of business about 3:30 in here in Lathrop. Yeah, this is our manufacturing facility here in Ripon. It's a 12-acre site. That's our trailers loaded at the output area of the plant, and 200,000 square foot of automation under the roof. Okay, this is a project that we worked on down in Manteca beside the Bass Pro shop. Of 297,000 square feet. Each one of them buildings we were putting to plate in about 9 days. So we cut the build cycle off that third job approximately in 5 months. If you always do what you did, you will always get what you always got. Thank you, and I hope that gives you some insight into what Integra does. If you have any questions.
Thank you, William. I really appreciate that. I'll start off with a question, and it might be used for both of you. And you mentioned this, William, about wood costs going up. What did you say, 350% or whatever it was? Wondering, given both of you are dealing with wood products and construction, where do you see wood going now? You know, there's been lots of articles and several publications about, everyone. Yeah, all the issues around wood and the uncertainty of the costs. What's the prediction, the magic ball reading on it?
Right. Well, I can maybe start. No, or Chelsea, maybe you want to.
I don't have a magic ball, but I look at the commodities price every day, and it's actually down a bit. So people do think it is coming back down. Where it's going to level out, that's the question. I know at least with mass timber manufacturers, they want projects to be successful. So they will work with you on what lock-in price you're hoping to get for wood fiber. So you don't have to pay that deposit up front. So, it's a volatile, wood market's volatile, but I know at least the mass timber manufacturers are really incentivized to make these projects successful. So the price of mass timber isn't going to be the same, volatility as just lumber.
With regards to lumber, yes, it has started to tail off a bit now, eventually, which is good. But we did see that increase there up until probably March, April of up to 350% of a rise from pre-COVID. Probably the biggest issue now is engineered wood products side of it is the TGIs, the YZs, the OSB sheathing, that sort of elements. Even truss plates now are becoming metal connectors are all becoming an issue, and hopefully that will ease. But then the market is so hot at the moment that everybody wants to build, and so we're at the mercy of the suppliers and of the people that manufacture the engineered wood and the sheathing. So it's just a supply and demand, and at the moment, demand is far outweighing the supply.
Right. I guess I have a little bit of follow-up question to that. This idea that both of these systems of mass timber and Integra both seem like things that you need to commit to earlier on than what you normally would. If you're just doing a wood frame building, you design it to the structural engineer, you design the layout, go to bid, and then one of the 5 union companies frames it, right? And these are both, need to be coordinated with MEP systems, and I guess engineered through. I don't know about the mass timber, how that works for engineering, but it sounds like you guys, Integra does some of their own structural engineering. So how does that change? Yeah, is that true? You get to lock in earlier, and how does that change the way architects and maybe contractors work?
Yes, it does. Ideally, yes, we want to be in early. We want to be in maybe 30-40% design meetings, things like that, where we can, and we do offer that service where, if you want us to have a look at your drawings, to say what you would see in terms of value engineering, but we ultimately don't maybe get the project. We offer that, I will go and I will sit, but you have to go right back to the root cause of some of the issues, not all of the issues. And that starts basically with the architect. So we're all in the industry long enough to know that a 8-foot one wall or 9-foot one wall is not framed on site at 9-foot one. Everybody knows that, but 99.9% of the drawings that we get in here, it's drawn at 9-foot one. The industry standard is 9 foot and 3/4 of an inch. The reason that is because that's pre-cut standard studs with double top plate and a single bottom plate gives you 9 foot and 3/4 of an inch. So if that process was implemented by the architect, that would save us so much time, because basically what we have to do is we have to redraw the whole architectural, bar the whistles and bells and the nice features, but basically we have to draw that because we have to tell the machine that wall is 9 foot and 3/4. We can't tell it it's 9'1" and then the machine will make a judgment. It can't do that. So that's the first point we have to start. A pet hate is bathtubs and showers. Every measurement I will see will be 5 foot 3.5 inches over. That gives you 5 foot clear. The plumber needs 1/4 of an inch to fit. So what I have to do then is I have to adjust that wall, move that wall from the architectural. So if the architectural is drawn as it should be built, that alleviates a lot of issues and time that we spend spinning our wheels trying to gather information. And probably it takes us maybe a week or 2 weeks to get an answer to a question that can probably be answered in 10 minutes. So that's why we like to get in early, and we get the chance to look at the value engineering as well.
Yeah, I think with mass timber, it's similar. We recommend getting a manufacturer involved in the DD phase. That way, by time things go into production, all the penetrations can be coordinated. Does it happen that way all the time? No. I was just on a mass timber construction site last week that they didn't coordinate any of the penetrations and they were drilling them on site. But each hole takes 8 minutes to drill. So it's really just, where's the efficiency and how efficient can it be? And that occurs if, you have the manufacturer up front and, similar to what William's saying, like all this pre-coordination, you want it to be as efficient as possible. But does that happen all the time? No, it doesn't.
Just like Chelsea said there, and she enlightened on it, 8 minutes. Minutes matter. That's what we preach our guys here is minutes matter.
Yeah. Anyone else have any questions? If you want to unmute and ask, go free.
I have some questions, William.
Yes.
That was really great presentation, and I think it's really interesting to see. And I think mass timber has a great place to fit in with that. You know, like the prefabricated walls and mass timber, and have that same level of precision from factory. I was curious, what size project is ideal for Integra? Like you showed a lot of different sizes, from single family homes to large projects. Like, what are you really looking for, and where is it optimized?
The first thing that we look for is repeatability. That's so if we go into, say, a development of 100 houses and we get repeatability of 5 plans, 4 elevations, that's good for us in terms of single family. In terms of multifamily, the higher we go, we can only go, I think at the moment, in 4 stories. At the moment in the type 3. So we look at multifamily, again, we're looking for repeatability. So if we have a development, now just looking at one here, and it's got 5 plan types and it's plug and play, that's the sort of product. So multifamily, repeatability on production homes, custom homes are something we wouldn't be too keen on doing, because it's probably like yourself, and you have to put a lot of value in, a lot of engineering just to get one output. So if it costs me X dollars to $1,000 to design, engineer one house, and I can repeat it 10 times, well, that's actually cost is then only $100. So repeatability is a big issue. But multifamily, commercial, single family is all good for us. Yeah.
Nice. Yeah, that makes a lot of sense. You mentioned that you're putting the plywood on everything in the factory. Is it inspected in the factory, or is that still site inspected by an inspector?
That is still site inspected by the inspector. Now, the reason that that is at the moment is because the factory house building code, as it is at the moment, is not set up for off-site companies. So basically, modular is more set up for that. So the way that inspection is done for a typical modular company is that if you have 4 elements in that wall, each one of them elements is, I think, $6.50 to get it inspected. So that's 4 times $6.50. I could have 100 components in a house, so that would be $6.50. So we're working with them at the moment to get an inspection process here. We have had inspectors come down into the factory and walk and see the product, and they're quite happy. But yes, the initial inspection, floor rim nail if it's required, shear nailing is inspected in the field by the city.
Yeah, that makes sense. I know it's interesting with modular, how it's kind of run by the state, and it's a whole different process. So a lot of things to work through with that. I think you might have said this, but maybe I missed it. Like, so are all the people who are constructing it on site are Integra employees, or do you work with builders?
We work with them. So
okay,
we have all our customers are builders. So we have a lot, probably 7 of the top 10 we're doing work for, and then we work for a lot of general GCs. But we do have turnkey, so it's a supply and erect, but we subcontract out to framers, and we have 5 framers that have various numbers of crews that we send all over Northern California to put the houses up for us.
Gotcha. So you mentioned MEP coordination, and I know that's a big issue with mass timber, is getting the MEP coordinated and the plumbers to agree to where does each pipe go. Like I know that—that's a big change for folks installing plumbing. How does that work?
Absolutely, that is a challenge. And again, I said on earlier, it's the pain before the gain. What we instill in the trade is, if you give us the information now up front, we will make your life so much easier. We will drill that hole. We do. I don't mind how you give me that information. You can put it on the back of a cigarette packet, or you can give a 3D model of it. As long as you get it to me. But what we find is that, particularly with some consultants who are doing MEPs, is they'll design it, and then the guy that's actually going to install it in the field will go and do something completely different.
Yes. That's been my experience as well.
You're not alone.
Yeah, areas to optimize.
Yes.
I think it's very interesting. Both of you guys, both systems, it takes a lot less labor, right? And when I first heard that from both of you, it's like, oh wow, there's this need. We're putting people out of business. But then, William, like when you had that chart that says that you're losing 5 for every 1 you bring in, it's like, well, you just kind of need to come up with these new systems to actually get skilled and to get really well done projects. And you don't have enough labor anyways to do it if you could hire a concrete crew as you normally would to build a floor. So I felt that was super interesting based on both of them.
We have the housing crisis. You know, we need to be able to build faster and cheaper. And I think this, you know, if we can really get this prefabrication really optimized and in use and all the steps in place, like this does seem like the answer, you know, just as William was presenting.
Yeah. A little after 1. Any questions from anyone else before we close out?
No, I'm good.
3, 2, 1. Well, thanks everyone for joining today. It was really great, and I really appreciate William and Chelsea, your knowledge and kind of new ways of thinking about things are really refreshing, and hopefully we can all institute those and make the Bay Area more equitable for everyone. So thank you so much.
Yeah, I'd just like to close on just a minute to say is you're all welcome, you know, to come up to Modesto to see our automated plant if you want to reach out to me or anybody in the AIA or whatever. If they would like to come up, we can arrange a tour and let you see what we do here.
Oh, that'd be great. Actually, we should do that. We should do a AIA tour to Modesto. That sounds like a great idea.
I'd love to come.
Yes,
I'll sign up.
It'd be a lot of fun. That's wonderful. All right, so have a good holiday week, everyone, and please join us again at the AIA Space.
Thank you.
Thank you.
Thank you.
Bye.